In this assignment, you were asked to read the case of Vanessa Culver and identify how she implemented each of the 8 effective mathematics teaching practices. The first effective practice is establishing mathematics goals to focus learning. So let's take a look at her goals. Ms. Culver wanted her students to understand that exponential functions grow by equal factors over equal intervals, and that the general equation y equals b to the exponent x tells you how many times to use space b as a factor. She also wanted her students to see the different ways that the function could be represented and connected. Ms. Culver wanted her students to have an understanding of exponential relationships that were behind the function notation. She just didn't throw up the function f of x equals b to the x and say, hey y'all, this is exponential. Okay, so I'm guilty of doing that myself. So we're all being honest here. She wanted her students to understand that the exponent tells you how many times to use that base. She wanted them to have that understanding of what exponential relationships are. And she also wanted students to make those connections between the different ways those relationships can be represented. The second effective practice is implementing tasks that promote reasoning and problem solving. Ms. Culver decided to use the pay it forward task. And again, she introduced this prior to students knowing anything about exponential functions. So let's read the task. It says, in the movie Pay It Forward, a student, Trevor, comes up with an idea that he thought could change the world. He decides to do a good deed for 3 people, and then each of these 3 people would do a good deed for 3 more people, and so on. He believed that before long there would be good deeds happening to billions of people. At stage 1 of the process, Trevor completes 3 good deeds. How does the number of good deeds grow from stage to stage? And how many good deeds would be completed at stage 5? Describe a function that would model the pay it forward process at any stage. So let's just talk about this task for a minute. This task is a high-level task. It requires a lot of thinking on the part of the students, especially if they don't know anything about exponential functions at this point. And Ms. Culver, first of all, wants her students to figure out how many good deeds are completed, or how does the number of good deeds grow from stage to stage, and how many good deeds are completed at stage 5. And once they do that, then they're supposed to come up with a generalized function. Notice here that she does not tell her students a strategy or require a specific method they have to use in order to solve this problem. And even if students have just a basic understanding, they can at least draw a tree diagram of stick figures to help figure it out and see the pattern. This task is open-ended, so students can approach it using any method they want to, from the tree diagram I just talked about, to graphs and tables, to actually writing the function equation, even if it's 3 times 3 times 3 times 3 with the dots that indicate that it continues. We want to get our students thinking here. For this type of task, in introducing this idea, we're not necessarily looking for correctness right off the bat. We want to focus in on that student thinking to direct them to the correct way of thinking about exponential relationships. Notice something else she did. She began the lesson by telling students, or by having students, work together in groups, and they again can use any means necessary to solve it. But she also provided them tools that they can use to help solve the problem. She gave them graph paper, chart paper, colored pencils, markers, rulers, graphing calculators. So students had the resources they needed to complete this task. And as they were working in their groups, Ms. Culver walked around the room and stopped at the different groups to listen in on their conversations. And she used that as an opportunity to do a couple of things. First of all, she posed purposeful questions as she was speaking to the different groups. How did you get that? How did the number of good deeds increase at each stage? How did you know? but she was allowing them to engage in the productive struggle. And when students struggled to figure out what to do, she encouraged them to try to visually represent what was going on and then see if they could find the pattern. Not once during this time did she show them how to do it or take over the thinking for them. Students were supported in their productive struggle. But as she made her way around the room, she also made note of the strategies students were using. That way she could decide which groups she wanted to have present during the whole class discussion. And each group would be expected to explain what they did and why they did it to answer questions. She's building that conceptual understanding of her students between the task that she selected and the way she's implementing the task. She's using the purposeful questions to generate discussion both in the small group, but also she uses purposeful questioning to generate mathematical discourse during the whole group instruction. She kicks off that instruction by asking, so who thinks that the equation y equals 3 times x best models the situation, and who thinks the equation y equals 3 to the x best models the situation? And she continues her questioning, and not once does she take over the discussion and tell them how to do anything. Her questions are strategic and gets her students thinking. But she also uses this mathematical discourse in her line of questioning to help her students see the connections between the different mathematical models. So let's take a look at the solution strategies students came up with. Group 1 came up with the equation y equals 3 times x. That's a misconception. Group 2 came up with the function y equals 3 to the x power. Group 3 started with a diagram like Group 4 and ended up writing it as a table because they saw the pattern. Group 5 came up with a function, a graph of a function, after they had done a table like Group 6 and 7. So through this activity, Ms. Culver was not only developing her students' conceptual understanding, but it was also allowing her to see what they were thinking and what they understood about the mathematics involved. And at the end of the lesson, she asked her students to explain in writing how the equation of the function y equals 3 to the x related to the diagram, to the table, the graph, and the context of the problem. That way, that gave her insight into what students still understood about exponential functions at the end of the lesson. All of these 8 effective teaching practices work together to build our students' conceptual understanding, but also their procedural fluency. And even though the procedural fluency was not evident here, it wasn't as strongly evident here, that initial pay it forward task is the first task you would have students engage in to start building their understanding and their procedural fluency. So now that you're finished with assignment 2, go ahead and post your discussion to the assignment 3 discussion forum. And once you've done that, make sure you complete the assignment 3 form verification.